computer, lights.
Good morning, everyone, and happy Tuesday. So we will be working today on why my lights are not right. It's not true. It's not what we're working on. I'm noticing, my Alexa is set up so that it gives me a timing thing where the lights change color. And Alexa gives me an auditory warning to tell me that we are at 10 minutes to show or 5 minutes to show or 1 minute to show. And that helps me kind of make sure that I stay on task and I don't lose track of stuff and things like that. So, but it's funny that today Alexa seems to have gotten confused and I lost a couple of my instructions. And so the lights were in weird colors and they weren't set up properly. They're still saying 5 minutes to show, and we are a minute after show. So anyway, okay, so today we're going to be working on some of the back stuff that goes on with our with this entire project of Bellatrix Rising. So let me go on ahead and switch over here. Here is an insane number of pieces of data. And I'll explain what's going on here. I wonder if I can take this camera and actually move it to right here, because this is a better and easier way of dealing with things, right? So if I were to make a monitor and duplicate it, monitor 2 with camera, we could. Oh, I like the fact that it doesn't even work at all. That's nice. You don't even have sound. Gone. I wanted to duplicate this guy. There we go. The monitor 2. We'll just delete that guy. We'll delete that guy. There we go. This monitor will switch from the ring camera, and I will make it the Logitech camera, or it won't work. I don't know. There's the other camera. Oh, let's see. Well, that didn't work at all, did it now? This or nothing. That. Can you even see this camera? I don't even think you can see it. That's weird. Yeah, well. Oh, that's even nicer. It has completely deactivated the ring camera. So I can't even fix it. Aw, what a bummer. Okay, well, we'll go over here and I'll delete you on this one, and then I will add a new source, audio source, or video source, video source. Hang with me here. Existing Logitech, there we go. Oh, there we are. See, you can see me now. And then I'll make me small. And that'll work. And now you can see me from this camera, which is good because now I can do sort of the same thing, but from over here where I can do this. And then I can look back here and go there. There. Okay. Because, frankly, I like using this screen for this kind of stuff. So we're going to go to the Ring camera, make sure that we have everything we need here. On this, we're going to move this guy over here. We're going to move this guy over here. Work. And then we'll go like this. And what we're going to do is we're going to set up the monitor to, not with me there on that. That seems like a bad idea. Let's set up the monitor to be work. Window capture. And not the drawing monitor. So we will delete the drawing monitor. And we will add a window capture, a display capture. Maybe this one. Yeah, there we go. There. There we go. And we'll move you to the bottom there so you can see me in the bottom right-hand corner. Yes, we have this under control. All right. The primary reason we're on this monitor is because this is a lot of data that I am processing at the moment. Okay. I took a lot. So we've got, what we have here is what we call the Hipparcos data. There was a probe that was put up in the 90s. And its job was to do parallax examination of stars. So it was a probe which orbited the sun. And as it orbited the sun, every time it was out, you can't even see, every time it was out, wow, this is a very narrow camera. When the probe would have the orbit out farthest from a point, it would take pictures of the stars. And then when it moved to the other side, it would take pictures from the other side. So the stars would move back and forth, and you could see which stars were in front and which stars were behind by the way that the parallax worked, right? Because the probe would move back and forth like this, and you'd see stars in front and stars behind, and you'd be able to tell how far they were. I have a program that we will get to at some point here. And this program allows me to visualize where those stars are in their actual locations. Right now, when you look at a star chart, it's always from Earth-centric point of view. It's always from our point of view, looking out into the sky. Here's this star, then there's this star, then this star. But you can't tell from the side whether these stars are way distant from each other or not. And I'll show that point here in a second. I will illustrate that. I did pass one on this already and came up with a wonderful representation. And here, I'll bring it up here. Wonderful representation of how this all works, sort of in its own kind of strange way. We need to find Oof, I closed the folder which contained, it's full of stars. There we are. So the program we're going to use is a little program called It's Full of Stars, right? And this is it right here. It's a little teeny program, very small, not very complicated at all. We're going to open. I have this Bellatrix main. Okay, so now we're looking at sort of where we are here. And this is Bellatrix, the home star in my story. And all around it now, you can see the stars that live around Bellatrix. Out here is Betelgeuse. That's the other shoulder of Orion, if you will. Looking the other direction, there's Earth right there. So what we're looking at here is a representation of the stars nearest Bellatrix. From Earth, this is the way it looks. Here's Betelgeuse, here's Bellatrix. These are the three stars of we'll go backwards to Earth. Here, there we are. Right, from our point of view. Right, here's Bellatrix, here's Betelgeuse. So these two form the shoulders of Orion. And right through here is the belt of Orion, if you will. The belt that, it's actually stars that are not quite this close. I don't think these are the three stars of Orion. The problem that we've got here is that all of these star pieces here are random. They're really not, they weren't clarified. And I'm noticing some things while putting these stars in. Some like groups, like there's this triumvirate of stars right here. That's interesting. I didn't know that was a thing. There's a pair of stars there. And these aren't close enough to be binaries. They are literally stars that are just really close. So that's what we're working on, Ghost Hand. Here's the data. Yay! Ta-da! So, and that's what we're after today. We're going to be working this data. We're going to be crunching the numbers. So this is my Hipparcos data. It comes from the Hipparcos satellite, which was the precursor to the Gaia satellite. The Gaia satellite's up there right now, orbiting the sun. And when it does, it takes pictures of stars. And what I was saying earlier was it looks for what we call the parallax, where the stars move back and forth like this. So as the satellite orbits the sun, stars that are closer will move faster back and forth. Stars that are farther away will move slower. And so you can get an accurate distance. Then we know an X and a Y and a Z axis of it. So this is the Hipparcos data right here. So these are real stars around Bellatrix. I just don't have the correct information on it at this point in time. But these are the right locations as far as Hipparcos sees. And so there's Earth right here. Now, as I was saying, there's Betelgeuse right there. And Bellatrix is right here in the center. Now, I made the map Bellatrix-centric. So the 0, 0, 0 on the map is Bellatrix. Work right there. So we're going to be working on that today. Not the most glamorous thing, but it'd be fun when we get to here. This is the part that's fun. So the thing is, I have down here, you'll see I have, not only do I have Excel with the Hipparcos data, but now I have Access coming up. Now, Access has NASA's planetary database in it now. So I have loaded the actual planets here. These are locations which have planets. So we're going to do some format checking here against the Hipparcos data to find which one of these stars has planets, and then add the planets that we know exist in, because that way this program actually will allow us to add planets into it. If we actually go into the system, you can see there's nothing in there right now but this weird giant construction thing. That's because I screwed up and put in the wrong data. Won't say anything. But each one of these can handle planetary data. So we'll be doing that next. So we've got our extrasolar planets. We've got our data. No, I don't want to save that. So we will now do a new quick query to this. And let's go ahead and set up our query. Okay, so we're going to take our extrasolar planets data and our Hipparcos data. So the cool thing is we can take a lot of the data from the Hipparcos side and move it down in here and then take whatever connects. But first, kind of like I've got the HD catalog here, and we're going to just put that up to the star name and connect it. And if you do that, we should get, here's our Hipparcos data. This is the actual catalog number, and I shouldn't use this one. I should use this one. I made a version that says HIP and then has that on there so that matches a little bit better. But if we do this, then we can do this. Well, first we should probably put the star name in, and the number of planets. And this will give us a connection. So there's 558 planets that we have already discovered using NASA data to these stars. So these stars now know, we now know that these stars, there we go. So these guys already have 2 planets. That's kind of cool. Holy crap. This one's got 4. That's cool. This one's got 6. That's a lot of data on that planet or on that system. There's a 5 planet system here and 4 here. Another 6 planets we've identified. Wow. We've done better than I thought. It's interesting because all we're doing here is just looking at numbers, but these are real planets. These are like locations out there in space somewhere. That's kind of fascinating to me. Okay. We've identified a number of planets now that fit the Hipparcos data as planetary systems, things like that. So we will, the way that we can code for this program allows us to add planets into the system. So we'll be able to just add the actual planets as they are. There's a lot of data on these. We know things like its orbital period, right? And we know its semi-major axis, its radius in Earths, its mass, and eccentricity. I am curious as to whether if we put the spectral type here and we put the spectral type here, I wonder if they're going to match. That's always something that gets me, because we've got two different data types. We've got one coming in from Hipparcos. Yeah, look at that. K2, K2. Look at this, though. G0 and an F7V. Are there two stars? We should check the stars, because this one also tells me the number of stars. So let's take that one too, where they don't match, right here. Number of stars, 2. So the primary is a G-class star, and its secondary is an F-class 7 star. Wow. That's a binary from hell. It's going to be fun. So there we go. So some of this data actually means something. I mean, all of this data means something. I find it absolutely spectacular to be able to see what's going on here. But more importantly, my Hipparcos catalog calls this one a G-class star, and it's not, the planet isn't orbiting the G, it's orbiting the F. That's a bigger star. So there's a mnemonic that we will use, which is "Oh, be a fine girl, kiss me later." Right? So OBAFG right? These are the star classes, going from largest O to smallest L. And we're a G-class star. The sun is a G-class star. So we're right in the middle. We're in the main phase, main sequence of our star. But an F-class star is a bigger star. So this information is kind of cool, because I'm getting information specifically about this system right here, which will ultimately be one of these guys, right? It'll end up being one of these. Now, the truth of the matter is my Hipparcos data covers literally 150,000 stars. So I don't think this guy's anywhere near Bellatrix. We'll have to see. We can find that information out if we want, right? Because this is the Bellatrix X right here, and the Bellatrix Y, and the Bellatrix Z. This will tell us how close it is to Bellatrix. Not very. So here's the same critter we were talking about. So it's 94 light years away on the Y, 13 light years away down, and 3 light years away on the other direction. So it's actually far enough away that it wouldn't be, this system wouldn't be in our little group. I try to capture only things that are within, say, 15 or so AUs of Bellatrix. That's what this ball is right here, is about 15 AUs. And that makes it easier to handle, because of course, if we load all 160,000 stars into here, we'll just have a mess of white. It'll just be all white. There'll be no way to see anything in the system. But there is one other thing that's interesting, is can you guys see the structure here? It's like in an angle going up right through here. And if you look at it, it has this angular pull, which means you can kind of see the structure of gravity pulling these stars down as they are pulled just a little inward, right? See that pull? And not only that, pulled this way, just heading that way from up here to down there. There's a gravity structure in here. It's interesting when you start pulling all these stars in, you start looking at sections of the galaxy from an objective point of view, instead of looking at it from a subjective point of view, because of course everything we look at is from Earth, and this data is, who knows what's in there. We could have things we're missing entirely. It just happens to be nice that stars happen to be lit up, So I am intrigued. Good heavens. Where's this data at? Look at that number. That's ridiculous. I'm going to have to drop these back to a reasonable number here. Okay, so we can at least see how close we are to Bellatrix. We can pare this information down to within 5 light years of Bellatrix 2. So we'll go ahead and do that. It's 15 and 15. We'll do the same thing here. We get nothing. So that means that within our bubble that we've created, there's nothing in the Hippocros catalog that I can use. We'll check the HD catalog. Nothing. The next thing we will try is the GL catalog. Oh, you don't even like that. Oh, because of the number of stars. Oops. GL, let's go to star name. Nothing. Okay, so the first thing I wanted to find out was, yes, I'm sure it's a really demanding program. The data that I'm crunching here is really demanding. This does allow us, though, first of all, if I take the extrasolar planets out, does it actually give me data? Okay, it does. 81 stars. Okay, that's exactly what I was looking for. So these are the 81 stars that are being pulled up right here. Right here. That's what we've got. These 81 stars. And that matches, and that's good. So, but it does mean that these critters right here are the only ones that are going to be in our fake little squadron zone here. And I'll double check to make absolutely sure that none of these stars have actual planets, because the big thing is, if, first of all, I like to be somewhat accurate, right? I mean, it's kind of useful. So if we were to make this way accurate, we can do this so it's not that big of a problem, right? All right, so we're going to check some important things. We need size, stellar class, temperature, constellation, and we need name. There we go. Now we've got the 81. The only star with a name in all of this is Bellatrix. That's funny. That's funny. So one of the things that did kind of strike me, you've got a lot of number out here. One of the things that did strike me as interesting on this is when we talk about Bellatrix, it's a stellar class 2, B2. It's a B2, B23, which is, that just gives us information on what kind of star it is. Bellatrix is a huge star. It's big. So when we talk about where the home world is for my story, it's a big star. It's a big star. And the 3s right here, these 3s, are about the same size as ours. So this is a 5 on a scale of 1 to 7. So that's where we are. It's a big, big star. Alrighty. So we need to trim to, what are we trimming to? So what we're also going to do now is we're going to make a pattern which we can export to this program. I would like to see Space Engine. Microsoft back in the 90s made something called Space Simulator. And you could take a rocket and get up into space, or just turn it on to free play. And when you turned it on to free play, it would just roll free and you could just fly anywhere in the galaxy. And at some point in time, the accuracy of its stars got wonky, and you flew out of real stars and into just dots that were flying by. And every time you stopped at a new system, it would just give the same like 12 planets. And so you'd be like, well, okay, I've been here already. And I get it. It was, everything had to fit on a CD-ROM. And so everything had to fit inside 600 megs. I feel like at the moment, my data file here is pushing 600 megs. So just this file that we're working on right now. So let's go on ahead and do some fixing in our Huygens data and our Hippocrates data. Okay, because one of the things we wanted to fix is some of these weird numbers. Because this is getting ridiculous. We've got exponents in some of these things. And I don't know where I'm getting all these numbers from. So there are restrictions for this program. Because it's X coordinate, Y coordinate, and Z coordinate is a 5-character float. So these guys have to be limited to gotta close that query. Yes, actually, we'll just call this Bellatrix range. Okay. We'll close that query because we can't edit the table unless we get in there. So here, we want to put this to 2, right? Okay, we're going to do the same thing here. I'm going to specifically set this for 2. Okay, and that way we get out here, it's still showing past 2. So we'll have to go fix this, obviously, because we need to trim to here, because the limit on the X, Y, and Z coordinate is 5 characters. And that includes this and that. Those two are considered 2 of the 5. So we're only going to be able to store that information right there. We'll be able to do 2, 3 decimal places there, but like 1, 2, 3, 4, 5, we're only going to catch to there on that. And when we get down to the places that are 100 out, it's going to get even less accurate. So there's that. A lot more than I thought are missing there. Constellation information. So there's 119,614 records in here. That's a lot of stars. 120,000 stars. Okay. Now we need to build a mask to go out and a form to feed the information to, I think. So that's a thing. The format that this needs to be in is very specific. So I'm going to create a form. Right? Something that'll be exportable. All right, so we'll make this. This is me thinking. This is going to be a continuous form. So I don't want to. This takes forever to do. I don't know if I like this during the show. I think I want to think about how I'm going to do this. So let's go to the next step real quick and see what we've got. I'll start up my lovely and talented drawing program. And it's taking a second. And we have a lot of things going at the same time right now. There we go. Boy, this is taking forever. And it went to the wrong monitor. I don't know why it does that. There we go. Righty. Here's what we're going to do. We're going to take, it's full of stars here, which is, we're going to try to find a position that we like. Shows as much as possible here. Zoom in. No, we don't actually want to zoom in because it's easier actually to see things. Zoomed out just slightly. There we go. And let's see, I think. Okay. Here, control print screen. We'll come over here. And we'll do file, new. I'm going to do an image. Looks good to me. I'm going to do paste. Take just this guy right here. Cut, paste. All right. Thank you. You're welcome. Take you. You're welcome. I think I'm funny. Okay. So now what we've done is I brought this into our drawing program. I'm going to show you what we're going to do with this. And take this guy here. We're going to desaturate him a little bit, right? Because we want to kind of just get an idea of what's going on here. And if we go in here, we've got a whole bunch of very low resolution sticks, right? That's not what we want. So we're going to want to get a better set of lines out of this. And one of the things that I want to kind of do is delineate up from down, right? Because we got Bellatrix right here in the dead center. All right, we got it right here. There's Bellatrix. So now we've got a number of these kind of sitting outside here stars. We can't tell which ones are up and which ones are down because it looks like lollipops. Everything looks like lollipops. Everything's coming up lollipops. So we're going to take this guy here. Bring it up. I'm going to take the technical pin. Bring him up in size. Well, he's there. We can just do this. Right? Gives us Bellatrix there as a black and white point. So this is the key center point of our entire map. We've got a number of these like stars. Like, let's start talking about some of these stars. Well, if they're above the line, then I'm going to actually put them up on top. So we're going to do this, a new raster layer here. And these guys are above the line. So we'll just real quickly have these guys as above the line. And I'll try to match sort of what we've got going on as far as size goes. And we'll just do this real quick here. Now, one of the reasons why I'm over on my other format over here is because these aren't accurate. That's just below the line, I think. So we'll just try to catch only the stars that are above the line. Which doesn't include Earth. Oops. These guys are all below. These are all below. He is above. Interesting that as we get a little further down here, it isn't that interesting, I guess. It doesn't make total sense. You and you. You guys. All right, these are all the stars that are above the grid. Now we'll do the same thing, but we'll do the stars below the grid. Includes Earth. Little dot way back there. Okay, so you're below the line. Right here, below the line, here, below the line. Most of this stuff is below the line, of course. I'm going to start right here in the middle. Makes sense. You're at the line. I feel like you're at the line. Way below the line. Make sure we've caught everything we can. Undo. All right. So the point that I'm trying to kind of get at here is that we've got stars below and stars above. The stars below we can kind of fade a little bit. Right. And then when we take this out, we can see which ones are below the line and which ones are above the line. Okay, easy enough. Now we just put the sticks in. So, oh boy, that's a big stick. That's not what we want. I don't want to speak that softly. Too little. Let's do 10. There we go. Now these sticks, they tell us about where each one of these stars intersects the Bellatrix line. It's always going to be kind of difficult to make star charts that are 3D and still are viable to understand and comprehend where things are. There's always going to be something weird. All right, so thanks. Oh, for crying out loud. We're determined to do little reading errors here. So when we do manual cartography of any sort, you kind of fudge the system a little, right? So we fudge a little as to where it actually shows up on the line because we don't want them to collide. We don't want lines to collide and stuff like that. So we'll sort of kind of fudge where it ends up going. So here we'll go with the top ones. It's like doing a whole bunch of lollipops here. But here's what I mean by fudging. These two are coming in really close on the line. It's the same spot there. This guy's like on top of itself there. Makes it really difficult to see where we're going. All right. This guy needs to be added because he didn't get added. These two were out here where I didn't notice that I hadn't put in a star. He's just way out here somewhere. So then there's a star right there that I missed. The thing is that we can do, the thing we can really do here, wow, it's just sitting on here, that we can, but doesn't it kind of capture your imagination? You look at all these stars and you think, all these little worlds, they're out here somewhere. All right. There we go. So now we've done this. Now we've done it. So we got the stars below and the stars above. We can take here and add a new layer. And rather than have a problem with that, we'll just do this. And then we can do this. And you can see through it now. So now we actually can kind of see through the bottom of this. And we'll add the Bellatrix grid in here. And that's what we'll do next. Bork, bork, bork. Put the grid in. Now, what really irritates me is that the grid that this program makes is not lined up 0 to 0 there. And I don't know why, but it really bothers me that that's the case. So we don't undo black. We actually don't want black. We want blue. Blue looks good. Blue always looks good. All right, we're just going to do this. I'm going to pull the grid to here. Now this is practice. So we're just practicing here. Because like I said, we need to redo the engine over here on my Access database so that I can make better maps. So the reason we're doing this manually, of course, is because the program, it's full of stars, which is the program we're using here, is ancient. And so this is extraordinarily low resolution, right? So if we were to look at this now we're getting a cleaner, better idea of where things are. We have some stars that aren't actually connected to the chart. I don't know why that is. Where are those guys? These guys need to have their stick. There. Noticing 3 stars didn't get picked up. This guy, because he's actually on the actual Bellatrix, which I don't know how that happened, but okay. You're just right here. So you're really close and you're on the same line. So that's interesting. And then you go to the top and then you. There we go. Now in a second here, we're going to pull away this underlying thing, because we need to make sure the stars are in first, and that's you. And who this belongs to. You need to go to here, and you need to go to there. One more right here. There we go. Now that we've done this, here's what the final basic star chart looks like. We're going to be kind of working with this now. All right. We're going to take then, and we're going to take this middle layer, and we're going to put a dot on the middle layer everywhere a star has impacted. This will help us find these stars. And cleans up this confusion a little bit.
It's time to take a quick break.
I'm going to take a break here in a second. I guess you don't go anywhere. The thing about this is that this gives us sort of a relevance. We now know where all these stars sort of impact on a 2D plane. We're 2D creatures. We really don't like 3D stuff that much. Not maps. 3D cartography is a little difficult. Right? What's funny is that many of my friends are trying to reason out why I'm spending so much time and brain power trying to suss out these maps. But the truth of the matter is that I really like to see and visualize where my story is. right? So let's go on ahead and real quickly, we've got a nice map going on here. Let's take a quick break. Bring this up. Switch to ring camera only. Everybody, time. Oh my goodness, stand up. Oh, that's not a bad idea. And stretch. Go for a quick little jaunt. Walk this way. And we'll walk back. And as we often do, take a look outside. Oh, is it clouding over again? We had sunlight. Come back. It's aggravating because we had sun and it was lovely outside, and then it has now switched to clouds. So that is a thing. All right. So this has made a map that looks more like a three-dimensional sort of engine sort of design, right? So if we go in here to the middle layer where everything is, we can give some data and information on this that's useful. Right? Symbology always is cool. Oh, this doesn't need it that way. There we go. Like, why is it so dim? There we go. So symbology is always sort of a cool thing, because we can use symbols to indicate different varying things, not the least of which is our core stars, things like that. The other thing we can do here is start talking in planes moving back. So things like moving further away from us. We have a number of stars that live in different planes, right? Not just this plane going down, but we could also give some distancing in this plane, and that would help us a lot as well, because then we can kind of see what's happening. And once they're all connected to the ground plane here, like this guy this entire front row here could be one different group, and the middle group here being a different group. We've got a number of stars that sit in this like middle row. We could do by each row. Wouldn't help us a lot with these two stars necessarily, but it might help us a lot with some of these back stars kind of going on. The reason I'm doing this, by the way, is because like I want to find out how I'm going to actually pull this off. So we know Sol lives way back there. We give it sort of an orange post so that you can see that it's Sol, right? Lives way out there. Undo. put that here, grab that, and go right like that. So that's soul's position. The soul position. I think I'm funny. Okay. When I move back over here, one of the other things we can do is do a complete 2D map, right? And then be able to actually see, hey, Allie, you haven't been here in a long time. No, you haven't. How's school going? Did you do good? Because, like, I'm always curious about these things. I know you were doing, was it A-levels? Are we still working on those? That's good. That's good. Good. So this is the most international that I've had now. I've got Ghost Hand in Brazil and you, Allie, over in the UK. So like way all over the world now. I just feel very international today. It's a very international day for me. We're working on stars. So interplanetary for us. And so that's a thing. Of course. Absolutely. Did you, have you been here on Fridays when we're here with Pepper? Pepper and his husband? Because that's sort of a thing. So, it was actually kind of funny because, oh, you're not here. You should be here whenever he's here. It was funny. I was driving with my niece the other day, and Pepper is making my pink paint right now for my Miyazaki set because I'm working on a Miyazaki set. And so I had to take, I have this powder. Excellent. I will call you Gray. I may not remember because I'm old, but if I don't, just remind me. Remind me that you are Gray. And I can figure that out because I don't want to dead name people. I hate dead naming people. I hate dead naming people, especially when I do it on accident. Anyway, was with my niece and we were driving along and I was taking my niece to school because she's roughly your age, give or take. I was taking her to school and I had Pepper. I had to take this powder to Pepper because he's going to make my pink paint for my Miyazaki set of paints over there. Okay. But I've got to finish the story before you lurk. Because this is a funny story because there's a gap now in all of our generations. You know, it's like I'm Gen X. I grew up in the 80s and stuff like that. And of course, my niece is your generation. So it's funny. I'm driving her to school and I called up Pepper and I was just talking to him for a minute because I needed to take this powder to him. And his husband, Bill, is a big Star Trek fan, Trekkie, just like me. So Bill and I actually get along really well because Bill is a Trekkie and Trekkies bond because we're all like Trekkies and crazy and stuff. So Bill was making all these jokes in the background and I was, and Pepper is like, you know, stop. We've got to talk business. And then I'm sitting there and talking to Bill and everything. And I didn't even think about it. And I hung up and my niece is like, you're really cool. And I'm like, why? I hadn't thought about it. What was it she said? She said swag. Like I was very swag.
And I was like, doesn't swag mean the extra stuff you get when you go to a convention? They give you a swag bag. So I was like, so I went over to Pepper's. I was like, here, Pepper, here's my paints. And by the way, you guys are so swag. And that became a joke for the next show. We just couldn't let swag go. Swag was a thing. Everything was swag. We were happy with that word. It became the word du jour. Because Pepper's roughly my generation. I think he's slightly younger than me. He's right on the border of Gen X and millennial. And so he's, anyway. So we didn't know what swag meant. So we just thought it was really funny. So apparently I'm swag. I just wanted you to know that. I have no idea what that means. But I'm swag, so there. And so is Pepper. Anyway, that's my story du jour, is that apparently we are all swag. We don't know what swag means. Okay, so it's good to see you, Gray. Welcome to the show. And we are now working on star maps. That's what we're doing. Oh, I missed a dot. It's like missing a spot. Instead of missing a dot. Okay, so what I have done here, take this technical pen and we'll raise it to 10. And we'll go right here. The star map should match roughly this guy. So we're taking that and we're going to come back over here. Paste. So now what I did was I took the map that we got from the program. Nope. Z. That's wrong. I got the map that we got. Look at it crunching those numbers. So this took a top-down only view of my star systems. So here they all are. Now, in theory, this should match our board down here. So Gray, when we started this, I was showing off some of the things that we're doing here. I'm trying to make a star map for my comic that I'm doing, Bellatrix Rising, which is centered around the star Bellatrix, which is the left shoulder of Orion. But since I like to be as accurate as possible, as much as I possibly can, so this isn't a random spattering of stars. This is actually from the Hipparcos satellite, which we sent up in the 90s from the ESA, actually. Your side of the pond, not my side of the pond. The ESA sent up a satellite called Hipparcos, which orbits the sun and takes pictures of stars. And it uses parallax, which is the when things move, as you can see, like my left hand looks like it's moving faster than my right hand, when really they're identical. But that's called parallax. So you have stars out there, and the Hipparcos satellite will take pictures of the stars from the left side of the sun and from the right side of the sun. And that gives us an idea of how far each star is and whether they're further away or closer to us. We've got a new satellite that the ESA sent up right now called Gaia. And Gaia has been refining this data, but it allows us to tell an X, Y, and Z coordinate of each star in the galaxy. Okay, and the cool part about this is that you can't actually you can actually make it so that, here, I'll bring over the chart. You can actually make it so that you can look at the stars in sort of a real-time aspect here. These are all the stars that are within 15 parsecs of Bellatrix. And there's Betelgeuse, right? So Betelgeuse is the other shoulder of Orion. And I actually put over here Earth. There's us. Work. Right? If you look from this point of view, you have to zoom in. Right? Move up a little. If you look from here, you can see here's Bellatrix, here's Betelgeuse, right? So from here, here's the two shoulders of Orion. These are other stars that some of them are not bright. They're closer to us, but they're not as bright. And that's actually what my second generation of data that I'm working on over here. I've taken the Hipparcos data and adjusted it because some of these stars I noticed are really big and really bright. And hey, Brent, everybody's on Twitch today. Brent has added the third key here. We've got Gray in from the UK, and we've got Ghost Hand from Brazil, and you from Kansas. So I am very international today, and we are now interstellar. Yeah, I mean, Ghost Hand's got a good question there, which is, I wonder what it will take for space exploration to really kick off. I don't know. So I'm a big fan of NASA. I know you guys are all shocked. NASA, JAXA, ESA. I don't care who gets up there. I'm even a fan of the Chinese Space Agency, although they freak me out a little because they're a little scary about their launch systems, but that's all right. The thing is, I think, yeah, I mean, mining helium-3 from the moon might be very useful. Helium-3 is really difficult to get on Earth. And so it's a complicated process. We can do it, but it's difficult. It's probably really honestly going to be cheaper to mine stuff from the belt. Yeah, I'm worried about that. The problem is that Earth is remarkably fragile, especially from orbit. I mean, I don't have to work really hard at all from orbit to do a lot of damage to Earth. A small chemical rocket on an asteroid no more than maybe a mile across, maybe. So 1.6 kilometers. And that's about all I need. If the asteroid's made of something heavy, like iron, then it won't burn up in the atmosphere. And all I got to do is drop it in the well. And then once I do, it hits Earth. And if I hit the Earth like on land, it'd be ugly. But it wouldn't be that bad. It'd probably put us into a couple of years of, nasty weather and stuff like that. But if I hit the ocean, which is a much higher chance, it'll vaporize a lot of water and put the water into the atmosphere, and we will go into a runaway greenhouse really fast. Really, really, really fast. So I'm a little uncomfortable with militarizing space. It's just too easy for people. It's like leveling up the nuclear war race that the USSR and the US were in. That's like a whole level up, right? Drop a rock. Well, okay, so that's the other thing. Being that I am on the edge of the Yellowstone supervolcano, I don't want anybody to drop a rock on the super volcano there, please. I mean, not to say that you guys are all going to be in better shape.
But Colorado is right on the edge of that thing. And that's a little uncomfortable. Yeah, maybe that's the thing, right? It's a rock. All I have to do is take a rock that's, I don't know. I think if it was solid enough and had enough of a enough heavy metal in it, I could probably do maybe 10, 15 meters wide, like a bullet, and it would just wipe out a city, depending on what its kinetic mass is. We could do the math, depending on, I mean, coming in from orbit, or worse, from high Earth orbit, just firing a kinetic missile onto the planet could take out an entire city. That's a lot of, and it would be just like you were saying, absolutely clean, because it wouldn't have any radiation. But the kinetic transfer, yeah, and you can all see what that did. Chicxulub, which is what he's talking about, the Chicxulub meteor was only about 12 kilometers across, 10 kilometers across, and it hit right in the middle of the Gulf of Mexico, which made the Gulf of Mexico. So, and in fact, if you look at the map of the Earth, if you look at Florida, Florida all the way around to Texas, to the Yucatan Peninsula, it's a crater. And so that was a big hit. We took a nasty, nasty hit there. So Chicxulub was a big hit. And actually, I think that Chicxulub, well, we all know what happened to Chicxulub because it hit 65 million years ago. So yep. So yeah, I mean, I'm uncomfortable with the idea of a military arm or a military space race. I do think that Elon Musk. Yeah, I know. Well, sci-fi authors have been using that for a long time. And really, it's kind of like defense against guns. Once that genie is out of the bottle, that's not going to be an easy one to stick back in. Like, how do you defend yourself against somebody who's got a pistol? Because body armor only does so much. And it's going to be the same way when we get to planets. The thing is, with a rail gun, I can accelerate a projectile up to a speed of which it would strike a planet so fast that nothing could see it and shoot at it in time. So you're going to have some science fiction effect, which is what I think I'm going to build into Bellatrix Rising. Some kind of laser shield. You know what I mean? It's magical. And if you fire at it, even in a split second, all you'd see is the grid just snap up and then go down. And when it does, it would just blow up the rod in the grid, and then it would turn off. So you could sit there and, I mean, that'd be kind of a thing. Yeah, it'd be a black box. How does it work? Magic. So anyway, so we were working on Bellatrix,
And check this out. I don't know if you've been here for a while there, Brent, but look at that. These are all the stars that are within 15 AUs of our home star. Home star. It's like home slice. Ghost hand. So if you look out there, we've got Betelgeuse. And I put Betelgeuse in just to kind of give a reference point, because really I think Betelgeuse at this point in time has blown up. And so it'll be a collapsed mess through this zone. Right. We know it's like the internet. How does the internet work? Does anybody even know? No, nobody knows. Nobody understands the internet. Okay. So what I was saying was, if we are correct, and we're always correct, we're going to, oh my gosh, gradient map. It's not what we want. Reverse gradient. Okay. Hey, Donald. Uh-oh. Now we're talking about explosions and things. You guys keep talking. I'm just going to work on my space map here. No arguing, though. The idea behind this show is to be not stressful. So no arguing. Okay. If I put this on darken, normal. We're just gonna real quickly take a look at this. Good morning. Okay, so if we did our homework correctly, then these dots should correspond with the red dots on our Bellatrix layer, on our primary layer, right? So these dots should come up somewhat accurately. So let's check that. Okay, we're going to distort. All right, coming in like this. There we go. It's like, which way are you going? And I actually, honestly, do not know. Legitimately do not know. All right. And I think, there we go. So we are trying to apparently make a mess of things. Okay, here we go. Move this there. Move that there. Move that there. This is much harder than it looks. All right. Okay, so I'm just trying to align, which is, I didn't realize this would be so hard. Apparently it is. There we go. In theory, Okay. Huh. Now we'll go in and double check. We're not that far off. Look at that. Look at that. Look at all these dots that almost line almost line up. Look at all these dots that almost line up. Didn't turn out bad. Not bad for a human. So, all right, guys. We're getting much closer to our target area here. So, the next thing I want to try to figure out is how are we going to portray like the gas clouds that are in here, because these are full of gas clouds that we're going to have to work with and figure out what to do with. And I think what I might do is do this by layer. So the gas clouds in this quadrant, and then the gas clouds in this quadrant, and then the gas clouds here, and the gas clouds here, and then here. Which may mean that I'm going to have to do each unit of stars sort of further back. This is all experimental. We're all trying to figure out how to do all of this. So let's try that. What I'm going to do here, I'm going to go in. This is our top layer. We're going to add a new raster layer. We're going to call this back area. We'll call this land. This land. And we shall call it this land. Call it your grave. Oh, curse your sudden but inevitable betrayal. And not having done a very good job on these things, let's go and we'll call this one 1, 2, 3, 4, 5. Alrighty. Let's go back and work on section 5. Section 5 has these stars going down. So they're yellowish stars, temporarily speaking. So we'll put in these. I like these 3 stars. I don't know who they are. We'll find out in a bit. And this guy lives in this section, but he's red. So we want to undo him and do red. So a red star. Okay. He's not quite, I guess he is kind of in that section, isn't he? All right, and then this guy's a blue star. And here, this guy. Right, he's a white star. He's on this side, so not a problem. But this guy's a little yellow star. He is part of our problem. So we'll put him down here. And then this guy's a white star. And then a yellow star right there. This little yellow, no. This guy's a red star. This guy's a yellow star. He goes to there. A red star right there. And then there's a yellow star out there. And then this yellow star. That's way out here. I thought there was somebody that was dropping really low on that far right side. So I was saying there was like a pattern to this whole thing. So, okay. So when we look at this, what we've got is, we'll turn off the Bellatrix. These are the stars. These are the stars that we have in this back layer. So we'll do this. I'm going to turn it down so you can easily see. Not you. You. Turn you down. Turn you down. Okay. Let's put our little posts in for this so that we can find these guys. That's not the post we want. Undo. Section 5. That's the post we want. Right. If you're wondering, this is all a learning process. I'm trying to figure out how to best depict this. White star that needs to. Right? How do we best depict this kind of thing? And then can we depict sort of a cloud through here? Right? How do we do that? Like, can we just take and just say, you know, we've got a kind of a cloud formation around this guy right here. And just kind of come out like so, and around. Sort of this kind of thing, you know, indicating sort of that this is a level back. And we've got kind of a cloud forming through this zone here. And maybe it kind of goes around this guy. We're trying something out here, guys, so bear with me. Let's see what we get. All right, so we'll kind of do this number. I'll kind of do this. Just kind of go up like that. I feel like if I fill this, it's not going to work like I want it to, but yeah, whatever. We'll give it a shot. All right, there you go. That didn't actually go as bad as I thought it would. Pretty sure that wasn't going to end right. I kind of have this going. All right. So if we were to add a new raster layer with section 4, and that's these stars through here, could I just maybe for each one of these just do a multiply? So it kind of, here's the cloud kind of going like this, and it's continuing. Yeah, I'm just making stuff up. Right? It's continuing through this zone here. I feel like this isn't going as well as I want it to, but ooh, darken? Nah, darken didn't work at all. Look at that. Normal. All right. I feel like section 5 would have to be markedly lighter than section 4. But it could be seen. There we go. So you're not that far off, my good man.
There will be, so I've been looking into gravitational string. There are these gravitational strings that tie stars together, and that's actually what I was talking about earlier when we were looking at the map here. You can kind of see sort of, let me pull back quite a ways. You can see sort of a thread that's going this way. It's pulling this way. And it's pulling from up here to down here. So the stars are in a way sweeping upward through there. And that's a gravitational thread. So there's gravity pulling in a way through there, and you can see the pattern as to how gravity is sort of ebbing through here. That fits sort of Einstein's general theory of relativity in a way. So when you are moving at certain speeds, you've got all kinds of weird problems you have to deal with. And one of the things that I have developed for our space travel in the comic is the faster you go, the more space-time distorts around you. So once you break the light barrier in these super light engines, that superluminal engines that don't operate in normal space, then space-time gets distorted. And as you go faster, you get larger warps in space-time. So, for example, when we look here at this system here, you can almost imagine that at a certain speed, these are the sizes of what we call oh, come on. I can't get the word Tannhauser out of my head, which is not what I'm looking for. There is a plane inside every gravitational object. Every planet inside it has what we call, I almost had it. Now I've got Schrodinger in my head. Almost had it. Schwarzschild radius. That took way too much effort for me to remember. The Schwarzschild radius is the spot where the mass of the object is so heavy that light itself turns around and falls back down. Every object has that, even you and I. It's just that our Schwarzschild radius is like a half of a billionth of a trillionth of a nanometer. So not very big. But like the planet Earth, it's actually like a kilometer across in the dead center, that Schwarzschild radius. The sun, it's like, well, no, in the center of the Earth, I think it's like 2 centimeters. So our Schwarzschild radius is about 2 centimeters. On the sun, it's about 3 kilometers in the dead center, right? So when you get to the point where you have a black hole, the black hole has crunched down its core to the point where that Schwarzschild radius is outside of the surface of the sun. When you have that, you end up with what we normally call your singularity and your event horizon, right? Because that event horizon is where all the light from that star moves out and then falls back down and just rains back onto the star, right? When you're using the superluminal engines in this comic book that I'm writing, the story, the Schwarzschild radius artificially increases in size the faster you go. So you get so fast that literally everything's the event horizon. You'll get sucked into a black hole, no matter what you do. So it becomes a navigational hazard. Oh, one of our streams is starting to die. I don't know if you guys can still see me. Hope you guys can still see me. But I am seeing the red light of doom there, which is saying that I might be not broadcasting anymore. The TLDR on this is, Donald, you're absolutely right. I've already sort of developed a universe where when you're at superluminal speeds, you're susceptible to gravity thread, you're susceptible to Schwarzschild radiuses that have been artificially expanded. Your ship is sensitive to the various pulls that are going through our galaxy. Obviously, there is a pull, right? Because our galaxy is in a spiral, and that means that the stars are being pulled around like they are all on a thread, right? And you can see some of these eddies internally. You know, it's not just one big arm like an octopus. Inside there's a whole bunch of curves and eddies and swirls where you'll have gravity twisting around and making coils, because something large will move through there, especially something large. You'll have something like a black hole move through a part of the arm of the galaxy. And when you do, as it moves, the gravity will eddy behind it. Because really, there's only two things that ever happen in our galaxy. And everything is a fluid dynamic. Everything moves like fluids. It just depends on how big you're looking. So even gravity moves like a fluid. Yeah, it just moves very slow. It's a very viscous fluid. But absolutely, stars move like mountains. They do move, they just move very slow. But when you hit the superluminal speeds, you hit the little button thingy to make the spaceship go pew, zoom, and take off at high speed or whatever. There's all of a sudden you're in the fluid. You become part of that gravity fluid that we have that holds our galaxy together. So, we're losing streams over here. I don't even know what's going to happen, man. I don't know what's going to happen. Okay. What do you know? What do you know? We're in charge. And Bill Paxton, talk about another of those losses that just came out of the blue. Losing Paxton sucked. So, anyway, we've got this wonderful sort of map going on here, but you can kind of see the pattern of the gravity eddy going this way through here. So when our starships leave Bellatrix, head this way, they're going against the gravity eddy, which will be pulling this way. So that's one of the reasons why I wanted to do this, was so I can kind of see where sort of visualize what this part of space looks like. And so I've got a lot of stars going up that way. So we'll have and it makes kind of sense because the galactic spin is to this way. So everything is moving this way galactically. The spin is heading this way, going over here to this part. But I find it interesting that we have a bump right here. The stars are moving like this over. So there's probably dark matter here, or there's something that the stars are moving over, something that's moving slower
thicker. This is all a birthing nebula through this area here. So things are being born. Bellatrix is a very young sun. In fact, it's so young that the planets are very, very young. And so young that the two inner planets of Bellatrix are still in the accretion disk, which is going to be kind of fun. So when you're in Bellatrix system, there's a ring, a hot ring around the inside of the star, and in there are two planets still forming inside the accretion disk, and it's because Bellatrix is really young. Right, there'll be whirls. There'll be like these spin-outs, depending on what's happening here. And so I'm going to go on ahead and artificially add something in here because that'll be fascinating. So down, we've got stars down here. So there's some density down here, but I'm looking at like this zone right here. And there's definitely like a hole right here. Now I'm not 100% sure because I still need to make my new data, which I will do in about 6 minutes when I get off the screen here, and we'll come back tomorrow and touch back in on it, and I'll tell you how that new data looked. Because right now these stars are kind of, the data that's loaded into this program is still a little uncomfortable, so the sizes aren't right, and it didn't know what it was doing, and I randomly put things in and got weird numbers. So we're going to have to go back and fix it. So you're absolutely right, though, Donald. You're starting to see now. Everything is a fluid dynamic. The world is all about slime and fluid. The universe is all about slime and fluid. So if you think about like how lava works, like when a volcano erupts and it spits things out and the stuff sticks together and comes back down, and it's like these globule slimy things. That's how the universe works, right? The gravity will pull, and then it'll break apart here and it'll break apart there. But then you get these gravity sludges, space particles. That's important, man. Space particles. I tell you. Put those. We've got to punish you for that beer kegger you had 2 nights ago. You're going to have to go out in a spacesuit and scrape off the space particles. I'm just saying. Maybe you'll use a laser. So, all of you guys who are, bad on my show, that's what we're doing, man. Anybody who's bad on my show, I'm just sending you out to scrape off space particles. Anyway, so I don't know. So the question then is, how do we make that look here? We can make some of this look cool by like half each one. We can actually kind of like bring these into each level, I think. Which will be cool. But I want to be able to indicate this dark matter area right through here, right? So probably could use section 4 that's here. And with section 4, we probably should like make sure it goes here. What are you doing? Goes down a little lower like this so that it looks right, so these are some of the stuff. Donald, look up Baryon Sweep. There's an entire episode about it called Starship Mine, in which Captain Picard went back to get his saddle for his horse and ran into Tim Russ. Yep. Starship Mine is the name of that episode. So,
it was season 5. I want to say season 5. Might have been 6. But anyway, had Tim Russ in there, not being Tuvok, which was kind of cool. Okay, so let's see here. We know we're going to have sort of an eddy going this way, so we kind of want to make sure that we indicate, there's fluid moving this way, which means if you're flying counter to this flow, and it actually is probably more like this too. So it's kind of coming up and over like so. That's kind of cool. Because then there'd be this large area down here. See? Kind of cool, actually. So we'll make a new map, and then we'll work on that on Thursday. And the other thing that we're going to do on Thursday is work on system maps. More important than our 3D maps are going to be the system maps. And the reason I say that is because when you arrive at a system, you have to still move at superluminal through the system. Because otherwise, you're going to end up, 6 light days out when you drop into the system. And we'll be like, whoop, we'll be there in like 2 weeks, for 2 weeks. And though that might be somewhat realistic, probably not very dramatically fun. So I don't know if that would be a thing that we want to do. Anyway, so we'll have to show the maps of where you jump in and how you can jump into a system. And it'll have because when you're moving at these superluminal speeds, it's still the same thing. You'll still have a Schwarzschild radius of the planet that will go beyond the planet, and all of a sudden your planets will be black holes. So you need to be able to navigate around the planets on an arrival approach to drop into a system. So if this is the plane of your system, so here's the star in the center with all the planets going this way, and here's your plane, you need to know to come in this way and not come in through the middle of the plane. Why are we flying through all these planets? Planets everywhere. Oh my God. So, and that's what we're going to do. But it is now time for me to head on and get lunch and go find my child, whom I presume is probably still asleep, but may not be. We'll have to go find out. We are now in summer break, so he might be asleep. He might be up already playing with a cat. Who knows what he's doing? Anything could happen at this point in time. So, Ghost Hand, Brent, Gray, Donald, thank you all for joining me today. I really appreciate it. I hope to see you all later, and all is good. And until then, I will see you later, and keep your eyes on the stars, and we'll be back tomorrow. Oh, and tomorrow, by the way, is Watercolor Wednesday, so
Hopefully, Pepper has my pink done, which means that I may have to go over to Pepper's house and get the pink. Let's see. If so, that could be fun. We could be having all kinds of fun. Or he might be making the pink tomorrow. Who knows? We'll find out tomorrow. Find out tomorrow on my show. Keep your eyes in the stars, guys. Bye-bye. Computer, good night.